Hey, hello there. Today's LeetCoding challenge question is called unique passes. We have a 2D grid, m rows, n columns. We're starting out on the top left corner, and we want to go to the bottom right corner. And our move set is that for one step, we can either go right or go down. That's the only two directions we can move. And the question is asking us to count the number of unique passes out there. So if we look at the board here, consider that we can only move right or going down. So let's just try out one of the paths. We have m different rows, so we can go down one row, go down two rows. So in total we go down m minus 1 rows. Once we reach bottom, we can try to go right. So that would take 1, 2, 3, 4, 5, 6. So that's m minus 1 columns, steps to move from bottom left to bottom right. So we can see that since we can only go right or go down, we couldn't go back. So all the passes here are going to be of m minus 1 plus m minus 1 total steps that we need to make to move from start to finish. And we also know that there are, among the n minus 1 plus n minus 1 total steps, there have to be n minus 1 steps for us to move down. Otherwise, we wouldn't be in the right row. So the question basically becomes a combination problem. So we want to count the number of ways we can pick n minus 1 steps out of the n minus 1 plus n minus 1 total. So that's essentially the mathematical solution to this. It's going to be linear time to calculating the factorial and the constant space. All we need is a few placeholder to keep track of the factorial number. So just going to summarize here in text. In total, we need to move n minus 1 plus n minus 1 steps. So the n minus 1 is for from top to bottom, and n minus 1 is from left to right. Whatever the passes, these two has to happen. It's just the problem where along the sequence of steps these steps are going to happen. So the question is basically choose n minus 1 out of the total steps. So that's n minus 1 plus n minus 1 steps. Yeah, so the formula for this C m plus n minus 2. This is on the upper is n minus 1. It's going to be n plus n minus 2 factorial divided by two things multiplied together. So that's n minus 1 factorial. And then also divide n minus 1 factorial. So that's just the mathematical formula for solving this. Let's do this by iteratively calculating the factorials from 1 to n plus n minus 2. Along the way, once we reach n minus 1 and n minus 1, we're going to store those. So let's do this. So the current value, we start with 1, and we're just going to do one loop from 1 to, so the factorial 0 factorial is 1, so that's now our starting point. We enumerating over the i's from I to n plus m minus 1. So the right hand side is exclusive, so we'll go the I in the last iteration will be n plus m minus 2. Every step we're just going to be multiply the I. So basically we're going to accumulating the count. You know that factorial is basically 1 multiplied by 2 and all the way towards this very last number there. So if I is equal to n minus 1, we're going to have a div 1, which is indicating this part. just be the current number. So in the end, we just are gonna return the cur, divide by div1, and then divide by div2. So I guess to initialize these two things, just in case that we have one row, one column, I don't want this two to be undefined, so they can initially they can be all be one in the beginning. Yeah, so that's pretty much the code. Yeah, let me try some more examples. Maybe 1 1 1 2 2 1, and something large 6 6 or 7 3. That's the example. Yeah, it's working. So yeah, there you have it. This is the mathematical solution to this. I think it's not easy to, it's not difficult to think about this. Basically, once you look at the board, you realize you couldn't go back, so there's no way you can have a longer path compared to the minimum. So all the unique paths from the start to the end has to have the same length, and we are moving exactly n minus 1 plus n minus 1 total steps. And the problem basically is just try to figure out, consider all the ways you can pick the step that you actually moved on, or it's equivalent to say that you want to find the number of ways you can choose n minus 1 steps you go down, or n minus 1 steps along the total that you go right. So that's the mathematical solution to this. And the runtime is linear, as you can see here. We enumerating over 1 to the total, and everything happening here is constant time operations. So that's the mathematical solution. If you do want a DP solution, we can do that too, because thinking about this grid and counting the number of ways, it's natural to think about DP2. The recursive solution is pretty simple. At any given position, you want to consider the number of ways you can get there. It's basically the sum of the number of ways you can get to the row above or the column towards left. So the relationship is really easy. Fmn is going to be equal to Fm minus 1 m plus Fm n minus 1. So that's the row above and the column towards left. And for base cases, we have F0i to be 1 and I0 to be 1 too. So let's just use j. So that's the two base case. Obviously, that the F00 is 1. So you notice that it only depends on the previous row or previous column. So we can compress this using just a one DP array. So let's just code this thing up. It's pretty simple. So yeah, so what we're gonna do is to, for row in range from 1 to n, because we can pre-populating the first row, and for column in range 1 to n, because the base case is also handled there, we don't need to do anything with that. All the code there will be just this recursive formula here. dpj, dp column is going to be dp from the previous row, which is just the value from the previous iteration, previous for loop iteration, plus dp column minus 1. In the end, we just return the last element on dp. So let's see if it works. It seems so. So that's accepted as well. Yeah, so this is the bottom-up DP with just one. What I have here is one row with n columns. Yeah, that's the two solutions. This one is going to be, you can see here, we have a nested loop here. So it's mn multiplied together. That's time. and the space is, you can see that we could take the minimum between those two. That changes the order you do things, but that's pretty much it. The mass solution is just n plus n, constant ink space. Alright, so that's this question today.